This video is Hypothesis Testing Full Examples Part 2. We're going to begin with Example 4, Family Practitioner Salary. The Bureau of Labor and Statistics reported that in May 2009, the mean annual earnings of all family practitioners in the United States was $168,550. A random sample of 55 family practitioners in Missouri that month had mean earnings of $154,590 with a standard deviation of 42,750. Do the data provide sufficient evidence to conclude that the mean salary for family practitioners in Missouri is less than the national average? So we want to see if the mean salary for family practitioners in Missouri is less than the national average. What's the national average? The national average, as reported in May 2009, was $168,550. So that is our null. That the mean, we're assuming, is $168,500. And that's what we have to assume until we prove otherwise. The alternate statement usually goes with the claim that the mean salary for family practitioners in Missouri is less than the national average of $168,500. Now, next we need to figure out what type of test that we need to run. So we need to run a test that tests the mean, so that's either a Z or a T. So we're going to go back and we're going to find the standard deviation. And here it is. Now, oops, I got a little more than I needed to. It says it has a standard deviation of $42,750. It does not tell us whether that's a population standard deviation or a sample standard deviation, so we have to use context clues. So let's read the entire sentence that it's in. A random sample of 55 family practitioners in Missouri that month had a mean earnings of $154,590 with a standard deviation of $42,750. So it is in the same sentence where they took the simple random sample. It's in the same sentence with the sample mean, so that means this has to be a sample standard deviation. And if it's a sample standard deviation, we are going to run, guess which kind of test? A t-test. Because we don't know the population standard deviation. What we know is the sample standard deviation. Now when you run this test, which I'll pull the calculator up in a moment for you, it's going to ask you the null. It's going to ask you for X bar. It's going to ask you for S. It's going to ask you for N. And it's going to ask you for your alternate statement. So our null was 168,500. Our X bar is our sample mean. So the sample mean of 55 family practitioners in Missouri that month had a mean earnings of $154,590. So 154,590. And then our S is our standard deviation, which I highlighted, 42,750. N, that's our sample size, that was 55. And then the last thing it's going to ask for is it's going to ask for our alternate statement, and our alternate statement is that it is less than. So you will choose the less than symbol. And looking over this, I see that I copied one of the numbers wrong. That's going to mess things up if I type it in that way in the calculator. It should be 168,550. Let's just check all the numbers real quick. 154,590, 42750, 55. I think we're okay. I've pulled up the calculator. We're going to go to Stat, arrow over to Tests. We're going to choose number 2 this time, T-Test. Now, I'm going to choose Data because they gave us the data. Or, I'm sorry, I'm going to choose Stats because they gave us the statistics. I'm going to arrow down and I'm going to put in 168550. And in X bar, I'm going to put 154590. For SX, that's the sample standard deviation, I'm going to put 42750. For the sample size, I'm going to put 55. And then for our alternate statement, I'm going to choose less than and hit enter. So you want to double check everything and make sure it's correct, and then we calculate. And remember, what we're looking for here is we're looking for the p-value. T is our test statistic in this case, so if you're on the homework and it asks for the test stat, that's your T. But what we need specifically for us is the p-value, 0.0094, 0.0094. Okay, hopefully I copied that right. 0.0094, and I'm going to compare this to 0.05 because that was our significance level. And looking at each number individually, those two were the same. 0 is less than 5, so 0.0094 is less than 0.05. And because it's less, we're going to reject the null. And if we reject the null, so because we reject the null, there is enough evidence to support the claim that the mean salary for family practitioners in Missouri is less than the national average. All right, it's your turn. Example 5, baby boy weight. Read through the example and then attempt to do the problem on your own. Make sure you hit pause first, and then when you hit unpause, we will have the answer up and ready. Okay, we're testing the pediatrician's claim that the mean weight of 1-year-old boys is greater than 25. Since we're testing a mean, we know it's a Z or a T test. So I searched for the standard deviation of 5.3 pounds. I read the sentence that it was in. Their mean weight was 25.5 pounds with a standard deviation of 5.3. That's in reference to the 360 1-year-old boys that were in the sample. So this is a sample standard deviation. 5.3 is a sample standard deviation, so we will be using a t-test. Mu is 25 because that's what the pediatrician claimed, that it's greater than 25, so we assume that it's equal to 25 for the null. Greater than 25 is the alternate statement. We fill in the blanks in the t-test, stat, test, choose number 2, t-test. Our p-value is 0.0372. Hopefully I typed everything in correctly, which is greater than the significance level of 0.01. If it's greater, then we fail to reject. That means it's likely to happen. It's not unlikely because it's not considered unusual, because it's not less than our significance level of 0.01. So we fail to reject the null. So there is not enough evidence to support the claim that the mean weight of 1-year-old baby boys is greater than 25 pounds. All right, pause the video and try number 6. Okay, we got a p-value that was something like 3.489 e to the negative 7, or something like that. So we're going to move the decimal 1, 2, 3, 4, 5, 6, 7 places to the left, adding 6 zeros in front of the 3. If I round to 4 decimal places, the 5th zero tells the 4th zero to stay a 0, and the p-value, we're just going to round to 0. Now when we compare that to our significance level of 0.05, that is definitely less than 0.05. If it is less, remember, we reject the null. And because we rejected the null, we can say that there is enough evidence to support the claim that the mean commute time is greater than 20 minutes. Now, just a couple things. I chose t-test because we were testing a mean, and they gave me the sample standard deviation. I know that because it's in the sentence where they took the sample. The sample mean one-way commute time was 22.8 minutes with a standard deviation of 17.9. This is the numbers right here. These are the numbers that I plugged in. Make sure you choose greater than. That actually will say greater than mu0 in the calculator. Alright, moving on. Okay, let's look at this one together. Example 7, job satisfaction. A nationwide survey of working adults indicates that only 50% of them are satisfied with their jobs. The president of a large company believes that more than 50% of employees at his company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them report that they are satisfied with their jobs. Can he conclude that more than 50% of employees at the company are satisfied with their jobs? Use a 0.05 level of significance. So let's locate the claim that we are trying to test here. So it asks, it shows his belief. He believes that more than 50% of employees at his company are satisfied with their jobs. But then down here it asks, can he conclude that more than 50% of employees at the company are satisfied with their jobs? So they kind of repeat that for us. So that's definitely the claim. Now notice you don't see the word mean in here, and also you see percentages. What are percentages? They're a type of proportion, just in a different format. So for our null, we're going to write, oops, I am writing the wrong thing. For our null, we're not going to use mu, we're going to use p for proportion. So we're going to assume that the proportion equals 50%, which is really 0.50 as a decimal, because that's how you would need to write it in the calculator or type it in the calculator. And for our null, we go with what he's trying to conclude, that the proportion is more than or greater than 50%. Now, we are not testing a mean, we are testing a proportion, so that means we're going to use a 1 crop z-test, and it's going to ask you for p0, which is the null, it's going to ask you for x, it's going to ask you for n, and it's going to ask you for p at the bottom, which is the alternate statement. So filling it in, P0 is your null, which we already said was 0.50 or 0.5. X is the number of people with the desired response. So it's the number of people that said they were satisfied with their job. So in his survey, 54 of them said that out of the 100 that he surveyed. N is 100. X is always smaller than N. X is always smaller than N. And then last, we need to match up with our alternate statement. P is greater than 0.50. Except we don't put 0.50 there, we put P0. That's what we're going to do. Okay, so let's run this test. We're going to do stat, test, and we're going to go down to number 5, 1 crop z-test. And it asks us for P0, which we said was 0.50. X is 54. N is 100. And it says, instead of saying P, it says prop. So the proportion is, we want it to be greater than P0. So it matches our alternate statement, and we calculate. And it looks like our p-value is 0.2119. And that is greater than our significance level of 0.05. So when it's greater, remember, we fail to reject the null. We're failing to reject the null. So we can't reject the null. We can't reject this right there. So we don't have enough evidence to conclude that it is greater than 0.5. So for the conclusion statement, we end up with there is not enough evidence to conclude that more than 50% of employees at the company are satisfied with their jobs. Okay, So we're going to stop the video here and pick up with part 3 with example 8.